Dear fellow coders, welcome to day 7 of Kaggle's Machine Learning Challenge, 30 Days of Machine Learning Challenge. In this lesson 7, day 7th, we are going to learn about working with external libraries. One of the reasons why Python is preferred over many other languages because it has got a rich ecosystem, high quality custom libraries that are written by somebody who wanted to contribute to open source, and how you can access that code by installing the library and how you can use it on your own work is what we're going to learn in this tutorial. So let's start with the tutorial. If you're new here, this is the place where I make programming coding tutorials focused on machine learning and data science. For you to do this thing, you have to be signed into your Kaggle account. If you're not familiar with that, I refer the first video. So in this tutorial, you will learn about imports in Python, some tips for working with libraries, unfamiliar libraries, and what kind of objects that they return. And finally, we'll look into operator overloading, which we have already seen in the previous sections. So what is import? We have previously discussed about functions, right? We have previously discussed about function, which is used for reusing a particular set of code. Function is primarily for you to reuse the block of a code again and again. So when you want to use a block of a code again and again, you better turn it into function. So you can call the function, pass on a certain arguments, get the result. That's what the function is. But what if you have a lot of functions? Like when you have a lot of functions, you combine all of these functions into one library. Okay, so if you have a code block, you combine them and create a function. If you have a lot of function, then you create a library out of it. And in Python especially, the reason why Python is again has been on rise recently with respect to data science is because Python has got a high quality number of high quality custom libraries that have been written by somebody else for you. For example, the library that we usually focus on data science, like NumPy, Pandas, scikit-learn. So these are libraries somebody else had written it and made it available for you for completely free. It's like somebody creating an Android application of very high quality and making it available for you, and that's why you would probably prefer Android, right? So the same way, somebody has created this high quality custom libraries, so you don't have to do everything from scratch, which means you don't have to write the function yourself. You can just call the function from these libraries and get things done from it. For example, very simple example, let's start with a library called math. Math is a very it's a standard library that's available in Python. Like when you have base Python, math is already available as part of the base Python. So when you look at math, you can see these are all the functions. For example, how do you import a library? First step, you import a library by saying import math. So you can either say import math, or you can say import math as with an alias, which we'll see in the upcoming section. So when you import math, you can say what type it is, right? This math, what type it is, type of math. So it's a class. It's a class of module. It's a type module. So this is library, package, module, all of these refer to the same thing. So math is a module, and a module is nothing but a collection of variables, like methods and whatever, like we can see the names like methods, functions, and variables, all these things like attributes, like collection of these things are a module. And what all values or variables or functions or methods that are present in math, you can see by doing like this. You can say dir, which refers to like directory. You can see the function name. You can give a function and you can print. So for example, you can see like square root is there, tan is there, tan h is there, pi is there, gcd is there, floor value is there, factorial is there, exponential is there. So all these functions, or it could be methods, or it could be attributes, is part of math module. So when you want to get pi, the simplest way to do that is use math.py. So basically you're saying I want pi, right, from this module math. So you say I want from math.py, then you get this pi value. Okay, so you have log also, like you can see here, log base 10, log 1p. So log, then again you just say math.log, then you get it. But if you want to know how to use log from math, so we have previously seen how to look for help when you are dealing with a function and a method. The same way, when you are looking for help from math log, then you can simply say help of math.log, and then it would say that okay, this is a help, like what is this? This is a help on built-in function log in module math, and then it takes one argument and you can give another argument. It returns a logarithm of x to the given base. So whatever base you give, it gives logarithm of that particular value. And then you can also, if you want to know for the entire library, so you can say help of math, and then that would give you the detail about the library itself, like what kind of functions are there, what is this library supposed to do, where do you find more reference for the library. These kind of informations you get when you say help of math, like the entire library, than just help of math.log, which is you are looking for a particular method or a function or attribute. So that's the difference. So this, like the help, again, like we have emphasized this multiple times in the previous videos, that it's quite helpful. In fact, it's very extremely helpful whenever you are dealing with a new library. Okay, so that is math. So math is a module. It has a bunch of functions, attributes, variables, whatever you would like to call them. It is there, and anytime you want to implement it, you don't have to, for example, implement a sign yourself, formula for sign. You can say math.sign, import math. Like the first step is you need to have math imported. That's the first step. Without that, math doesn't exist. So you need to first import, which means everything from this namespace, like everything from this universe comes into your session. So you get to access that using math dot. Okay, so that is how it is. So after you import all these functions, everything is accessible to you. The next thing that I just was talking about, we have seen previously, is instead of importing it with the full name, you can import it with an alias. So import math as empty is an alias here. So instead of importing with math, empty is an alias. Now you might ask me, what is the advantage? Like, why do I need to import it with an alias? The advantage is, imagine now this is like 4 characters, import math. Okay, so everywhere you can give math dot, that's fine. But imagine you have a library name which is like huge. For example, let's say TensorFlow. Now, do you want to mention TensorFlow every time you use a method or function class from TensorFlow? You may not want to do that. So instead, what you might want to do that is, you might want to import TensorFlow as TF. That's the usual notation. You can use anything, there is no restriction, but if you use the standard ones, anybody who reads your code, they might have a better understanding. So import TensorFlow as TF. So you know that TF dot something whenever you do, so you know that function or that method has to come from TensorFlow. So instead of writing the entire TensorFlow on dot, you can do that. And like for example, the common convention in like popular machine learning libraries, import NumPy as NP, import pandas as PD, import Matplotlib, like from Matplotlib you will import pyplot as PLT, then TensorFlow as TF. Like this is like quite common. Then the next thing is, either you can import it as alias like this, or you can do it like this. I mean, like this is much preferable. This is what people usually do. So this adds another line, it might create confusion. So you can just stick to that. One more thing which is quite common again at the starting point, but usually not very preferable when you start writing production level codes and a lot of lines of code, is from math import star. So basically you are telling Python, give me everything that is available from math. So why it is usually preferable for beginners? So you don't have to say math dot anywhere you do this thing. So it eliminates that redundancy of writing that library name, module name, and then calling that method or function. So that gives you flexibility of just simply writing the function name and then getting things done, or a variable name. So that way it is good. In what way it is bad? It is bad because now it's going to already import a lot of variables into your namespace which you are not going to use. Imagine there is a library that has like 1000 or 2000 or 3000 variables. Now what will you do if you import everything? Does it make sense? No, it doesn't make sense. So it is always good to import only what matters, but this also works. So this imports everything, every variable from this math module directly to you without having the dotted prefix. So I mean, like so they're calling this kind of people as purist, and I would say like you can do this only when it is necessary, but it is always good to be explicit and mention what kind of functions or methods or variables you want to import, so that you don't fall into this star. Like once you start doing the star, right, you will end up doing star for everything, which is not a good thing, because soon enough you might write a code which needs to be optimized, which needs to be efficient. So always, like for example, if you know pi is the only function that you need from math, you don't need anything. Or let's say pi and log, just do from math import pi comma log, that's it, enough. You don't need star. So in case in the future if you need one more function, you can always go back to your top, like the top section where you usually import the libraries, and then say pi comma log comma sign, that's it. Now you can start using sign. You don't need star, because a lot of things you may not end up using it, and then it's just there sitting in your session, and it might consume memory. It is not a good coding practice, and I know they have called people like me as purist, but it's a good practice. It's always a good practice. It's good to written good kind of code. Next, like if you do like this, from math import slash, from numpy import slash, what has happened? So the problem is, what has happened here is, both these libraries, both numpy and math, has a function or a variable called log. Now both of them work differently. Okay, so now because you use star, the other disadvantage is there is a confusion. So when you do, everything is imported. Now you might think that the log that you are using is from math library, but the log that you are using here, it is referring back to numpy library. So to avoid this problem, like this is a problem, right? When you have multiple libraries, two different developers might have named their variable like in the same name. So to avoid that, just simply from math import log and pi, because you want log and pi. From numpy you import as array, because that's what you want. So now there is no collision between the functions or methods or variables that you have across different libraries, modules. Okay, so that takes us to the first quick introduction about modules, how we import modules. Now we are going to enter into another concept called submodules. Now what is submodules? So we saw that a module can have multiple variables, like it could be a function, it could be an attribute, it could be a method, it could be anything, right? Now what we can see is there are certain types of variables that refer to other modules within a module. So that kind of module is a submodule. For example, inside numpy you have random. Okay, numpy.random. Now this random is not a function, this random is not a method. This random, if you see the type of this random, it itself is a module, and then you can see what kind of variables are present inside it. So numpy is the main module. Inside numpy you have got random, and now that random, is it a function, is it a variable, is it a method? No, it is another module. That's why we call it submodule, and you can see what kind of variable names, functions or methods available within this random. For example, numpy.random.seed, you can set seed. numpy.random.shuffle to shuffle your random variables. numpy.random.test, numpy.random.standard exponential. So you can do all these things. So basically, like for example, if you want random numbers from a given range of numbers, so you would say numpy.random.randint, like from 1 to 6 give me 10 random numbers. So how do you do that? So if you have import numpy as np, so you would say np.random.randint. But on the other hand, if you had said from numpy import random, if you had done that, you can simply use randint. Okay, so these things, the more number of codes that you see, the better you would get clarity around it. Again, these things, like there is nothing for you to memorize, you just have to write more and more codes, then you will get familiar with this. Matplotlib is another library where you would see a lot of these things, like the usual thing that we would do is from matplotlib import pyplot as plt. So now, like pyplot is like a subclass, and then plt dot you would do a lot of things. So you would come across similar stuff in a lot of different libraries related to data science. You should definitely read about it, but right now you may not need all those things. Okay, so if you think the object that you are dealing with is a different type, for example, basic type, we have seen integers, we have seen float, we have seen booleans, we have seen list, string, dictionary, tuples. These are the things that we have used, like base data structures we have seen. But we have also seen, when we say type, we see module. Sometimes you might see a numpy array as a type, sometimes you might see a pandas data frame as a type. So this section is going to help you understand those kind of types and how you can identify. For example, in this case, we have created a numpy array. So what type it is, you can use a function type and then pass on that object and then get what type it is, what is there in the function. sorry, what is there in the object. And then you can use dir and then identify what kind of methods and attributes this type of an object, which is a numpy array, can take. For example, if you see numpy array dot ravel, you can do numpy array dot sum, you can do numpy array dot shape, numpy array dot mean, numpy array dot flatten. You can do these things on a numpy array. So when you do dir of any object, because it's an numpy array, it will list everything that you can do on a numpy array. So the variables, the methods that you can do, the attributes. So for example, that's the example that they've given. So now because mean is present here, mean. So now numpy array, the array dot mean. So that will give you the mean. So instead of iterating through something and then finding out mean, you can just like the entire, for this entire array, you can just put dot mean and then you can get it. And if you want to convert it to list from the numpy array, if you want to convert it into list, you can do toList, and everything that you can actually pretty much figure out here what is in it. And if you still do not know, the simplest way is what? Just put that method name in the help and then you would get help. For example, roles.ravel. So if you do not know ravel, so what ravel does, you can say roles.ravel and then it would say, okay, ravels, it takes a numpy array and then returns a flattened array, and you can see the full documentation here. And then you can see other related functions that are somehow related to this. So help is again extremely important. First one type, second one dir, third one help, and then that takes us to the end of this section, where we learned about modules, we learned about submodules, we learned about the type of functions that can help you deal with modules where strange data types other than integer, boolean, list, string, dictionary might get returned. So that will give you some clarity about what kind of data type, how do you want to deal with this. So this is basically everything related to libraries. What I might also do in the description is I might give you a bunch of important library names, not a lot, bunch of important library names. Just go look at it. For example, I think in the previous video I had spoken about regular expression. So there is a nice library in Python for regular expression that is RE. So RE, import RE. Now RE stands for regular expression. That's a nice library. For example, if you want interactive visualization, there is a library called Plotly. Okay, Plotly is an interactive visualization library. You can just read about it. There is a library called Seaborn. So I'll give you a list of like a few library names that you should definitely check out. You don't have to know everything that happens inside it, but you can just look at it. That will help you. Okay, so that takes us to the end of module section. In the next section, we are going to learn about operator overloading. Operator overloading is a very important concept in object-oriented programming. We have already seen a very quick introduction to object-oriented programming, where we said everything inside an object-oriented programming is accessed through an object. So class is defined. Everything within a class is accessed through an object. So one class can have, like, you can create multiple objects and then you can start accessing it. So now what is operator overloading? Operator overloading is nothing but you have one operator and then you overload them for different purposes based on what you have got. For example, if you have got something like plus, you can use it for string concatenation. We have seen already. You can use it for addition. You can use it for different purposes. And this concept is called operator overloading because you overload this operator for a different purpose. So instead of using it for additional arithmetic sum, you are using it for a different purpose, and that's what operator overloading. Okay. So now what is the error? The error is you have got an array and then you are using plus and then you are using an integer. So it says basically cannot concatenate list to a list. Oh, sorry, it says I can concatenate only list to a list, not an integer. I cannot use an integer, and we have got an integer here. Now, so what is happening? What is the difference? For example, this list, this 10 did not sum. This is a scalar value. This is a list. It did not sum. This said it will not work out. But if you take the numpy array that we created above, and then we use the same plus, and then we say 10. It's going to add everything. So the same thing that did not work here, but the same thing is working here. And why does it happen? It happens because NumPy has handled this operator overloading, so that anytime you have a NumPy array and you have a scalar value, these operators would work. For example, plus or in or equal to. So all these things have different purposes when you deal with a NumPy array. For example, usually when you say less than 3, when you do like this, when you have an array and then less than 3, it is not probably going to take this less than and then compare it with every single element. But what happens in a NumPy world is this scalar value, this single value is matched with every single element of the NumPy array. So for every single element of the NumPy array, it is going to match it, like evaluate it, and then it is going to return like false, false, true, true, false. So for every single element in the NumPy array, it's going to match, and then it's going to give the result. So again, this is operator overloading, because NumPy has overloaded this operator which was not otherwise possible. So NumPy has made it in such a way that this value is taken and then compared with every single NumPy element. So that is what, like that is why this is this is possible. That's why this is happening. The next thing is so a couple of examples are there. You should definitely go through it. So okay, now let's come to TensorFlow operator overloading. Import TensorFlow as TF. TensorFlow, if you are not familiar with TensorFlow is the library for you to do deep learning using Python. TensorFlow is from Google, so there is another popular library called PyTorch. That's again like from Facebook Artificial Intelligence Research. So again, when I say it's from them, it's not paid or anything, it's open source. So this operator overloading, they're saying like it can get weirder when you start using deep learning libraries. For example, TensorFlow as TF, you have one constant, b is 1. When you add them together, what you get is not 2. You're not getting 2. 1 plus 1, you're not getting 2. Why you are not getting 2? You are actually getting a tensor in return. You are getting a tensor in return, and the reason is because now you can actually read to it what is they have mentioned in the TensorFlow documentation. A symbolic handle to one of the outputs of an operation. It does not hold the value of that operation's output, but instead provides a meaning of computing those values in a TensorFlow TF session. So now this does not create a value. It does not take these two values and sum. So what it does is it gives a guidance when TF.session is called. During a TF session, TensorFlow session, this will tell the TensorFlow session how to compute, a means of computing those values than actually holding the values. So again, this might be a little confusing at the start. This might be slightly overwhelming, but simply think that when you see a plus, it is not always additional arithmetic sum. When you see less than equal to, it's not always a simple logical operator. What you see may not be true. Like it's like in the Matrix, the kid says to Neo, you can do that because there is no spoon. The same way, it's not a plus. You can do anything with a plus because operator overloading can make that plus into anything. And every library, for example, NumPy would treat plus into some way. TensorFlow would do something with plus. So they just keep changing these things. So you can basically like every symbol, every operator might have lot of set of different values, so you don't have to be scared of it, or you don't have to be confused about it. This section is primarily intended to show you that these kind of things exist for different types, different object types. Operator overloading might come into play, and then the operator might do something else than what you think it might supposed to do. So if you are interested in how these kind of things work, you can actually check with the operator type, object type. For example, you can say list of dir. Now what kind of things you can actually do with the list. Okay, so you can actually see, and then you can start training those things. And the next thing is, for example, just before we close out the final things, so what you can do is you can go to the official documentation of Python, and then you can have a look at this section which is talking about operator overloading. and then the special method names that they are saying, like how everything changes for one another thing. For example, less than equal to greater than equal to, how things change. So you can read about it. So basically you can go to the Python's official documentation and see how special underscore methods work. Why? Because special underscore methods, so these methods actually give you different functions. Like when you have this double underscore, and when you give something, so this double underscore format gives you a different meaning, like it makes you do something different. So that's why people define something like that. But if you are not clear, doesn't matter. You can just take it when you just move along. You don't have to memorize any of these things. Just remember that everything that you see does not mean what you see. Simple. Something could be happening behind the scene, probably because of operator overloading. Plus may not be plus all the time. Something else could be happening. Sometimes it's a string concatenation, sometimes it's an arithmetic plus, sometimes it's a TensorFlow operation, depending upon which library you have imported. So just be specific about the library that you import, so you know what is happening behind those operators. Now that takes us to the end of this final section of Python. So we have successfully completed 7 days of Python basics. So I hope at the end of this you might be better in your Python skill, or at least like quite a revision. So let's quickly see what kind of questions they have asked. And like I say, usually you should probably stop the video at this point and then move on to solving your exercise yourself. That will give you some idea about how to do things. So they have a few solution. They have few problems. Once again, I'm not probably going to do this thing, so I would request you to do this exercise. If you have any comments, please let me know in the comment section. Otherwise, I would pretty much request you to do this thing. It's quite simple. For example, it's quite detailed, and then they are telling you what kind of things you have to do, and if you just follow it, you can do it yourself without even googling much. So that will give you some understanding about whatever we have learned. So basically in this section you're going to learn about importing a library, and then you're going to start for example, in this case you're going to see Matplotlib library and do a couple of things with Matplotlib library. If you're stuck, let me know in the comment section, so I can probably make a separate video altogether. But if you are not, good luck with your exercises. So we have successfully managed to finish Python in 7 days. I mean, again, this is not going to make a Python expert. Python is a lot more than whatever we have done. But we have learned about base Python, we have learned about functions, we have learned about booleans and conditions, we learned about list, we learned about loops and list comprehension, and we learned about strings and dictionary in the previous day. And then finally we learned about working with external libraries, and that takes us to the end of the 7-day journey. Let's hope that we can make it through the 30 days together. If you have any comments, let me know in the comment section. Otherwise, spread the word. Happy programming. Stay safe.